are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
Hi guys, many thanks for the invitation you sent me, and it's a great pleasure for me to speak on this event. So this evening, or in Europe, or this afternoon in US, I'm going to speak about digital twins in the construction industry. So today's presentation will cover topics such as what are the digital twins indeed, then the relationship between BIM and digital twins technologies. Why do we need digital twins? Especially because there is some skepsis in BIM world. Do we need digital twins, and what's digital twin indeed? Then digital tools, of simulation in the digital twins technology, savings that can be achieved with digital twins, and some examples at the end of my presentation. If I have some time, I will also share some good examples of web-based BIM and digital twins models. So yeah, we can start with the topic, what are the digital twins? The best definition of digital twins could be that the digital twin is a digital replica of physical data, process, system, and digital simulation of reality, which can be used for various purposes. So no matter does the some building, a ship, airplane, or whatever exists or not, or it's in a design stage or in construction stage, we can use the tools which digital twin technology allows us to do. Yeah, you will see in the next slides how we can play with the tools that digital twins technology allows us. So for the beginning, I just try to explain very simplified what is the purpose of digital twin. Well, if we imagine that we want to test the strength of eye, for example, single eye, yeah? So we want to test it, but we don't want to break it. And this is like this is the likely option. And option without any damage is to test it in digital world, because after we run the test, we can set up new eye and test it once again. While in a natural environment or in reality, we would break the eye. So yeah, it's a damage that cannot be recovered. How the whole idea started in 70s, NASA was testing some twins, not digital twins, but I would say twins, where they tried to do simulations on small-scale objects about the technology of creating a digital twin model in the format we now know, which is an existing or designed object, and identical copy of object in digital format was created in 2002 and was firstly used again for in astronomy by NASA, yeah, for the production of various components and systems for different suppliers. So we can say that digital twins have been used primarily to calculate the life cycle at the beginning of journey, for the life cycle, to calculate the life cycle of component systems and various assemblies and structures after installation, production, and construction. Primarily, digital twins were used to estimate the cost of maintaining different components, systems, and buildings by making various simulations of phenomena and processes that would occur on existing objects using their digital format replicas. I assume that you have concluded that by accessing a digital replica of existing building, for example, component or system, and simulating the various real-world impacts on them, we come to the, I would say, information on all aspects and causes of life cycle costs of a particular object, component, or systems in real-world environment and in a real-world impact of different phenomena and interaction between building or some objects, in this case, space shuttle. So, yeah, where we the most commonly use digital twins technology nowadays. So we can say that we are using that in a manufacturing industry, or we could say automotive is always the pioneer in industry. In I would say Earth planet industry. I don't speak now about NASA. So the first digital twins in industry started with car crash and collision tests, which I will show you later. Then it's very commonly now used also in the construction industry, and this is why I'm trying to present it today. And also in medical, not industry, but the area of medical science, where various aspects of, for example, arterial mechanics or pressure of fluids in human body can be tested without any damage to human body. So, like the story with the eye, we want to test the heart, but we don't want to break it. And yeah, this is very good example where digital twins technology can be used in real world requirements. So the relationship between BIM and digital twins technologies, because nowadays I think we have unclear or not strictly clear breaking line which breaks BIM and digital twin technology. So I tried to give I'll try to give some explanation how I see that BIM and digital twins technologies are overlapping and how they can help each other. So in the design, we can say that, okay, we cannot design without BIM, but we can live without the digital twins because we already were able to do the design without digital twins, but they are very helpful. So we can say that it's 50-50 preference for digital technologies, digital twins technology. Then if you go to construction, we are speaking about 4D, and 4D doesn't necessarily include digital twins technology. But when we come to real-time operational changes in the digital model, BIM becomes a little bit slow and is not responding properly to all changes that are happening in a digital model itself, while a digital twin is a perfect tool and perfect technology to reflect all the changes in a real building, I would say, and or any object in our case, and also when we speak about focus on life cycle of the building, I think BIM might be used, but it's much easier to use digital twins technology than simply because of dynamics, because we have dynamic impact of many phenomena from the nature happening on a real building, for example. So we cannot do those simulations in BIM, and we can rather than do them in a digital twins environment. Parameters of building exploitation, like sensors, IoT, data gathering and processing. I think BIM cannot fully respond to those tasks, while digital twins technology is the best tool for these tasks. And finally, simulation of dynamic processes such as CFD, optimization of functionality. I would say also some other like energy efficiency and so on. I think digital technologies took the supremacy over BIM because, again, BIM is mostly design tool, while DT can also deal with dynamic processes which are happening in a building. So, the relationship between BIM and digital twins technologies can be defined that BIM model can be considered as a starting point of the digital twin development, or without BIM model, we cannot do digital twin development, simple like that. Why do we need digital twins? So in BIM world, we know, I mean, most of you know, I probably don't need to explain what does it mean 3D, 4D, 5D, 6D, and 7D. But when we come to maintenance, then we have a problem with the dynamics again, and with dynamic impact of an environment. So when we speak about the digital twins during the design and construction, a good example is car crash test, which is fantastic tool to test the car and not to break the car. So it makes car, I would say, model development much cheaper. That can be also done with buildings with dynamic impacts such as wind. And in bottom right corner, there is an image which is not so dynamic, but indeed there is a test where you can test the corridors and evacuation during the fire in a building, or some. We also did some tests in Arup where we were testing. For example, blue guys are curious, red guys are in a rush, and I don't know, orange guys are. They like to see, for example, or what's happening in the fashion stores. So depending on different preferences of humans in a group, we could simulate how the behavior of group happening in a corridor, such as elevator stairs, or corridors like such as the area of where for pedestrians mainly. Yeah. In this case, I think we did a test for underground station in London. And I think this is where we should use definitely digital twins during the design and construction. So I think dynamic impacts also can be considered for in the design phases, different design phases. Now, when we speak about buildings which are already constructed, we speak mostly about again, BIM takes us to maintenance, and then we have requirements to measure something, to optimize the documentation, to be able to click on a certain element in a digital twin and to find out all the properties of that element, which partially allows us also, BIM allows us also to do that. But what we cannot do in BIM is to check when the building is constructed, does the building behaviors in the same way as we designed it during our design stages. So then we come to the issue that we want to measure how our design was done. Then for the client needs, we can do audit or permanent audit by using digital twin. You know that we can increase the energy efficiency. But if we say that we can do it permanently and by measuring some values using different sensors and then transferring the data through IoT into cloud, and then analyze that data, so we can say that we can permanently optimize semi-automatically, automatically, or by human decision. But the most important thing is that we are dealing with real data collected from real building and real environment, or like a natural environment. So digital twins, digital tools of simulation in the digital twins technology. Typically, we use CFD as a tool to test the models in the design phases, and I think this is the best way to try our design in a digital environment. Then, once the building is constructed, then we speak about sensors, which are collecting real-time data. Then we speak about IoT. Python is the most preferred in my case. Sorry if I'm if I made mistake by anyone's opinion, but yeah, Python is the most preferred data science tool for that data analysis and also it's the step into machine learning and artificial intelligence, which are the most sophisticated areas where we create semi-automatical or automatical systems which can make the decisions made on data which was gathered by or collected by sensors. And yeah, what digital twins technology allows us. So the first and the most valuable thing is that it allows us to make data-driven decisions. So it's not subjective thing where you can say, oh, I want this or that, or I think it's 30 degrees or 25 degrees, so I need a heating or cooling, no matter what is the decision. First of all, we are speaking about results which are measured through sensors, then transferred to IoT up into cloud. And yeah, it's definitely one of the biggest advantages is that of digital twins technology is that we can make data-driven decisions, and this is something which we definitely want to do now and in the future. So now few words about savings that can be achieved with digital twins. So yeah, first of all, I think in the future we cannot expect that the price of urban construction land will be cheaper, or we cannot expect that the price will drop. So the only segment where we can, where an investor can make some savings is to optimize the design, to optimize the construction, and to optimize the life cycle of the building and equipment in that building. So also to optimize energy efficiency. So I think if we permanently apply digital twins technology from design up to construction and then up to maintenance, I think we can make great savings to investor. Or if I would be an investor, I would insist to apply digital twins technology on my investment. Then by applying BIM workflow, or we can say also digital twin workflow and digital twins, with the proper BIM management and complete BIM project process, somewhere between 5 and 15% more problems have been processed in early design stages, which takes us to the better design at the end. And this data, to be honest, I took this data from Lend-Lease, and because we have a great collaboration with them, so there was a questionnaire, and then we discussed about say 10 years ago projects and projects which are happening now when we apply BIM and the digital twins in full capacity, and as they said, between let's say 10% more problems are spotted in early design stages. So imagine that you can save, for example, space reserved for risers and have that as a commercial area and not technical area. So this is something which is really worth to consider. Then we also can, the use of different sensors in building which generate data through the data platforms help to automate equipment, as I mentioned earlier. So very simple, like when we are testing permanently, or say on hourly basis, if we measure the temperature in a certain rooms or spaces or corridors or wherever we want, wherever we define, we can optimize the energy efficiency of the area of building or of overall building. And I think after building is constructed, so I also have a data that something like without any big any big research, by simple audit, energy efficiency can be improved by at least 5% for each building constructed between say 70s and 2000, for example, because in that time there was no during the design and construction, people didn't consider so much about energy efficiency and insulation materials and jalousies and the optimization of the equipment in the building. Also, there are big financial savings, I would say, because by analyzing the data collected through the sensors in already fabricated and constructed objects in the design process, the investor makes significant savings in the speed of fabrication or construction of the building. What we are also doing in Arup is that we are collecting experience and user experience from our clients, and at the end we collect, for example, the design for typical usage of or type of building, and then we have predefined solutions for certain type of building or factory, for example, or I don't know, for retail. So yeah, we have some specifications, and this is, we call that collective mind, where we collect how successful we were in our previous projects. So by implementing the conclusions from previous projects, we can make significant savings to our clients. Finally, and the most important, in my opinion, we are coming to the saving which can be achieved with a digital twins technology. That by analyzing the data collected through the sensors, we can save the world, which is the name of or the idea of today's event. So if we are in line with the SDG or Sustainable Development Goals developed by UN, we are taking our planet into we are making our planet to be a better place for life. And definitely digital twins technology, as you could see in the previous slides, can help in energy efficiency, which, if you just say energy efficiency, that's enough, but there are many different aspects, such as avoiding to construct something and then test it, while we can do it in digital space without leaving that environment. So I think we are coming near to the end of my presentation. So the digital twins examples. So in Arup, we have developed Arup Carbon digital tool. And this is very simple app application, which is working together with the Speckle data transforming platform. But the aim of Arup Carbon Digital Tool is to link digital design models to the whole life carbon calculations. So in that case, we can rapidly quantify and reduce the carbon dioxide equivalent emissions and associate it with our design. So during our design, we are all the time monitoring the emission of CO2. In doing this, we are acting to achieve United Nations Sustainable Development Goals, specifically 9, 12, 13, and 15. And this tool enables the user to, I would say, interactively with view carbon hotspots in their design in BIM or digital twin environment. The visual interactive carbon analysis summary can be shared very simple with colleagues. So during the design process, we can see what is the total of carbon dioxide we produced in our design, and then we can optimize, discuss with the client, and optimize our design again to save the world. A very simple example of monitoring, I think I explained in some of previous slides, where we are monitoring also our offices, and we are trying to make some lessons learned, and also to optimize our space where we are working and optimizing energy efficiency in the same time. Finally, I have some example which is not from Arup, but from a company which I'm writing articles to, and they have developed some fantastic digital tool which can manage. The name of that application is BIM Real Estate, and with that application, which is totally customizable, you can manage either rent. In this case, this is a rental of the existing flats. The most important thing is that maybe I'll have a few minutes. Maybe I don't. Few minutes. So maybe I shouldn't speak too much about this. Maybe I can share with you. But also,
Predrag, you're right that your scheduled time ends at 5:30. So if people are going to hop to other sessions, that's fine. But you know, we actually have a break after your session. So if you want to run a little bit over, that's totally fine. And anybody who wants to stay can stay. Okay,
thank you very much. Okay, so in this app, indeed, it comes from Revit, and then it's built on Forge platform. All the data is sitting in a flat area, I would say. So on the bottom left slide, there is a possibility to select the floor and then to select the flat. And then there is also a possibility to walk through. But what's a real benefit of this tool is that there is a customizable database behind everything. So the database is filled, and for example, energy consumption on some issues in maintenance are also recorded in that database. And for example, the rental company can control each building through iPhone or Google, I would say Android platform, and all the data which is available in database is also accessible from mobile phones. So I think it's fantastic tool because it doesn't require from anyone to have a Revit knowledge, to have a training about Navisworks or tools which we are using for BIM. But indeed, we can call this web digital twin, where if I just if I just go to this app, so it's sitting in a browser in Chrome. We can switch on, switch off furniture. We can switch on shaders. We can go to 4th floor and go to apartment number 17. And we have the data. I mean, this is only for public purpose. So we have areas and so on. Inside the database, we have also all the data related to that flat, like energy consumption and I don't know, I mean, this is the most important thing for real estate. But yeah, I think this is very, very cool thing, because this is also accessible from mobile phone or smartphone. So I think this is also a fantastic example of how we can optimize the real estate industry by using this sort of digital twins, in this case web-based, because it's unlikely to expect that everyone will accept Revit and robust Autodesk solutions or any other solutions, while with a web-based model placed in Chrome, I mean, everyone, even my daughter, she's 12 years old, she can play around. I mean, she was playing around with this model, and she was able to read the area. I mean, it's very simple for use. So thank you very much for your time. I was trying to be as quick as possible. So I'm happy to see if there are any questions, or I can answer later. What's the...
Excellent. So yeah, first of all, thank you very, very much, Predrag. Excellent presentation, and we appreciate you making time today for us. Just like with the other sessions, we're going to direct questions and answers to the Slack channel. So anybody who has questions for Predrag, please join us in the Slack channel now or later on, and you can definitely connect that way. Again, thank you very much.
No problem. Yeah, it's glad to be your guest. So yeah, pleasure is also mine. Thank you very much for your time.